inverse variation and inverse proportionality, they mean the same thing, and applications. So y varies inversely as x. What does that mean? Y equals k over x, meaning when x goes up, x gets bigger, it's bigger in the denominator, so that whole fraction becomes smaller, so y becomes smaller. When x goes up, y goes down, and vice versa. When x goes down, y goes up. Y is inversely proportional to x. It means x times y is equal to k, but if that's true, then just divide over by x on both sides, and you get this equation again. So just use this one. Okay, see those x's would cancel out, and you get y equals k over x, which is this. Okay, so that's the one you're going to use for both cases. Alright, here's an example. The value of a car varies inversely, or they could have said is inversely proportional to the time the car was first sold. So evidently, the car values goes down when the time since you bought it goes up. That makes sense. After 3 years, the value of the car was $25,000. Find its value after 10 years. Well, as the time goes on, the value is dropping, so we expect it to be a lot less than $25,000. But anyway, here is the equation. The value of the car is inversely proportional to the time. I could have used something better like v equals k over t, but that's okay. We'll go with this. Y equals k over x. So plugging in the information, it was $25,000 after 3 years. This, we always do this to find the k. Multiply both sides by 3. K is 75,000. Then take the equation, use the k you just found, y equals 75,000 over x. Find its value after 10 years, so the time is t, you plug in here. Y equals $7,500. So the value will be $7,500 after 10 years. Note, this particular math model breaks down at the start when t equals 0 years, because the model predicts the car was valued at y equals 75,000 over 0, which is infinity dollars. So sometimes a math model only works over a certain range of values. Okay, another example. The intensity of light, L, varies inversely as the square of the distance d from the source. So here's the light source. The farther you are away from it, then the intensity goes down. So the distance goes up, the intensity goes down. That's an inverse relationship. Of course, they also could have said, instead of varies inversely, they could have said is inversely proportional. So they can use either one of those two phrases and you pretty much do the same thing. So the intensity of the light is inversely proportional to the square of the distance from it. And so that's the setup. We got to find this k. So they give us some information. The illumination is 2 foot candles when it's 5 feet away from the light. 5 feet away. So you square that according to the formula. You get 25 on the bottom. Multiply both sides by 25 and you get k equals 50. Now you use the 50 back in the equation. I equals 50 over d squared. they want to know now, find the intensity when you're 20 feet from the light. So that's 20 down here for the D. So you square that down there, and it's 550 over 400, which reduces to 5 over 40, which reduces to 1/8, or you could say 0.125. Anyway, the intensity is 1/8 foot candle. So the farther you are away, the less the intensity. That's an inverse relationship.